Assalamu alaikum everyone. Thank you very much for joining this webinar. It's going to be very exciting and you're going to love it, inshallah. So I have disabled the voices and the videos for all of you for the time being, because the mode of this webinar is going to be one way for the first 30 minutes. And in the next 10 or 15 minutes, we are going to take questions from your side. And if you have any query, we are going to answer that, inshallah. So let's wait for a couple of seconds for the rest of the people to join, and then we will, inshallah, start. Okay, let's start today's session. I hope that everybody can listen to me and can see me. Let me give you a brief introduction about myself first. My name is Ishan Akram, and I am an electronic engineer from Pakistan. Building drones is one of my hobbies, apart from my academic background and my professional career. Apart from building drones, my hobbies include robotics, automation, Internet of Things, machine learning, artificial intelligence, Python programming, and last least but not least is the Arduino and Android application development. I have been conducting different workshops on these subjects for last couple of years worldwide, especially in Saudi Arabia. Today's webinar is going to be on kind of a head start on building drones. This webinar is to give you a guideline about this technology, that what kind of this technology is and how you can enter into the technology and how you can start working on it. So let's start. Bismillahirrahmanirrahim. So first of all, let's see what are drones. Drones basically are unmanned aerial vehicles or UAVs, and these are special vehicles or aircrafts that do not have a pilot. You must have seen an helicopter or aeroplane that is flew by a pilot, but drones, they are unmanned aircrafts, and these aircrafts are controlled from the ground station through different technologies. So a drone is basically an unpiloted or unmanned aerial vehicle or an aircraft. A drone is basically a broad term used to describe any kind of unmanned aerial vehicle or UAV. Quadcopter is a more specific term used to refer to a drone that is controlled by 4 rotors. So there's a difference between a drone and quadcopter. When you listen the word of drone, you must have get a warning in your mind that we are talking about some military operations, and we are talking about something which are doing the bombardment or doing spying. Okay, but our specific webinar, the specific webinar is related to a type of drone which are called copters. Copters or a quadcopter is the same thing, and quadcopter is basically a type of a copter. So how many type of copters we have in the world of UAVs? We have a unicopter that is contain only one copter. Okay, as you can see on the image. Then we have a bicopter that consists of 2 rotors. Then we have a tricopter. We have a quadcopter. So it's uni, bi, tri, and all these terms, they refer to the number of rotors a copter can have. So it's a quadcopter containing 4 rotors. Then we have a pentacopter, hexacopter, octocopter, and so on. Okay, so the octocopter is basically the finest one and the most heaviest one till my knowledge. And these copters are used in different ways as per the requirement or as per the hobby of the flyer. And all these copters basically are flying on the same principle. How these copters are built, how they fly, and where they are used, we are going to explore this in this quick and exciting webinar, inshallah. Okay, so first of all, let's see where these drones are used. Drones are used in multiple industries in multiple ways. Drones can be used to deliver objects, your parcels from one place to another. Amazon and some other companies, they are using these services. You place an order, the Amazon drone or quadcopter picks up your order from the warehouse and drops at your specific safe location in your lawn, outside your apartment, outside your home, wherever. They are also used for racing. They are also used for the military operations. They are used in the telecom sector to monitor the towers where it's difficult to reach. Drones or quadcopters are also used for cinematography, for making videos of different places where you have visited, or they can be used in the farms, in the agriculture. If you want to monitor your farms, your agriculture area, and you want to do some sprays of pesticides, or you want to do some kind of monitoring. The latest of these uses are the taxi, a drone taxi. Drones are being used as your limousine or a taxi, and very soon you are going to see this technology in the real world. Not long ago, it was seemed to be a dream, but very soon you will be seeing flying taxis around you. Drones are also used as a fire extinguishers, as you can see in this image, that 3 of the drones are basically trying to control a building which is on fire. So quadcopters, copters or drones, they have multiple uses and they are very popular, and it's not an old technology, it's evolving, and we have different uh, advancements in this particular field. Guys, for the new joiners who just joined, the format of this webinar will be one-to-one. I'm going to speak first for the first 25 to 30 minutes. I'm going to explain each and every subject. And at the end, we are going to have 10 to 15 minutes question and answer session. Don't worry about the presentation. I'm going to share the presentation with all of you. And the video recording will also be shared. So if you miss anything, you can later come back to me, send me an email or send me a message, and I'm going to explain to you, inshallah. Okay, so we have explored that where we can use these drones or these quadcopters. Okay, so let's see how drones fly. As a common man or a person who's into this beautiful world for the first time, he must be thinking that in the case of a quadcopter having 4 rotors, what I have to do is I just have to rotate or move those 4 rotors in the same direction so that my quadcopter takes off from the ground. Okay. So when a drone is flying, there are multiple forces or there are multiple movements that are ongoing in this case. On the screen, you are seeing a particular case of a quadcopter. consisting of 4 rotors. And you can see that I have put some terms called yaw, roll, throttle, neck. Neck is also known as a pitch. So these are some of the forces that are acting on a quadcopter to control it. Let's explore one by one what are these forces and how they behave. Yaw refers to the direction the front of the drone is facing. So as you can see in the image, there is a particular quadcopter. The yaw is basically rotating your quadcopter in a clockwise or anti-clockwise direction in a horizontal plane. So if your quadcopter is in this direction, okay, is in this way horizontal. So a yaw basically rotates it in the clockwise or anti-clockwise direction. Okay, so this is called a yaw movement. Then we have a pitch. Pitch means the drone tilts upwards or downwards based on its orientation and the location of its nose. The nose of the drone is the front side. This is the nose of the drone. Okay, so the pitch is basically moving like how this drone is going to move outwards or downwards based on the orientation of the nose. If you can see in the image, the drone is basically tilting and then tilting on the right side and the left side. So this is a pitch movement. Yaw is basically rotating on the axis. The pitch is basically tilting. And the roll is basically another type of movement that moves your quadcopter in a roll direction. So these are 3 basic movements of a quadcopter. These movements exist in all kind of copters, be it hexacopter, pentacopter, tricopter. So any kind of copter, it has these 3 basic movements. The throttle is basically the power of the quadcopter that moves the copter outward or downward. So if you increase the throttle, the copter is going to rise into the air, kind of a takeoff. And a negative throttle, or if you decrease the throttle amount, it's going to lower the height of the quadcopter, and it's kind of a landing movement, or if you want to decrease the altitude of your copter. Okay, so we have basically 3 movements: yaw, pitch, roll. The throttle is a special movement that's basically increasing or decreasing the altitude of your copter. Again, for the new joiners, please note down your questions on a separate paper. At the end of the workshop, after like 20 minutes or 25 minutes, I'm going to let you ask questions that you have noted down. This is to make sure that there is no interference or there is no disturbance or distraction during the webinar. I appreciate you will understand that. Okay, net. As I told you in the start of the previous slide, that you must be thinking that in order to fly a copter, the rotors of the copter must be moving. Yes, definitely. And they must be moving in the same direction because I want to move the copter upward direction. Okay, but you are wrong, unfortunately. But nothing to be discouraged, because this is something new you are going to learn during this webinar, that what is the dynamics that is controlling the copters in the real world. In actual, the direction of the rotors on a copter, they are same on one axis and opposite on the other axis. Why is that? You must have heard about Uncle Newton, Mr. Newton. He's a very famous guy, and all of us have heard about its famous Newton's first law of motion, second law of motion, third law of motion, and he discovered gravity. So this guy has a very famous law, which is the third law of motion. As per Newton's third law of motion, every action has an equal reaction but in the opposite direction. You can see on this image of a boat, the person is trying to lean forward, which is an action, and as a reaction, his feet is pushing the boat backwards with the same force. This is a natural law which was discovered by Newton. So based on the same law, if all motors rotate in the same direction, like I said in earlier, if 1, 2, 3, 4, all of them are rotating in clockwise or anti-clockwise, all of them, then the quadcopter will keep rotating in that direction. The cause and effect is an important function to understand with quadcopter blade rotation. Okay, so that's why in order to counteract this torque effect, okay, which is cause and effect, we have to make sure that the copter's rotors, they are rotating in the same direction on one axis and opposite direction on the other axis. So in this image on the left side, you can see that the rotor 1 and 3, they are rotating in clockwise direction. 2 and 4, they are rotating in the anti-clockwise direction. So this is how we are counteracting the torque effect, and we keep the motors in this direction so that we have the cause and effect motion as per instructed by Mr. Newton. So this is very, very important because I have seen myself and I have been through this incident that if any of these motors is not rotating in a right direction, okay, you can have a serious accident with your quadcopter, which include a damage to yourself and yourself as well. So make sure that the direction of your rotors or your motors, they are in the right way. Okay, this slide is going to tell you that how you can maneuver or how you can move your quadcopter in different ways. Like if you want to control your yaw, roll, or pitch, and a throttle, how you can do that. Okay, so I have 8 scenarios in this image. The scenario number A is basically the yaw. How yaw is working. If you see in this image, my rotor number 2 and 4, they are thicker than 1 and 3. Thicker means they are rotating at a higher speed. They are putting a higher thrust as compared to 1 and 3. Because of this, I'm going to have an anti-clockwise yaw. Okay. And if you want to have a clockwise yaw, you will do the opposite. That is, you are going to decrease the thrust or the rotation speed or the RPM of 2 and 4 and increase the RPM or thrust on 1 and 3. And in order to take off, you want to take off. So what you will do, you have to increase the thrust of all the 4 rotors, 1, 2, 3, and 4 at equal speed in the same direction as we have discovered before. So the copter is going to rise from the ground. It's going to take off. And if you want to land it or if you want to decrease the altitude, what you have to do that you have to decrease the thrust or the rotation speed of all the 4 rotors in the same amount so that it can lie down till it lands on the ground or it reaches the altitude, the decreased altitude as per your requirements. So E and F and other diagrams, they are going to show you that how you can change or you can control the thrust of the motor to have a particular motion of your copter. So in order to control the yaw, roll, pitch, and your takeoff and landing, you have to change the thrust of the particular motors so that you can achieve that motion. I'll keep this slide for a couple of seconds so that you can understand, and if you have any question, we are going to address that at the end of this webinar, inshallah. Okay, now let's see how you can build a drone or a copter, what components you need. What are these components? We are going to discover that. Before this slide, we went through all the basic theory of the copters, how the copters work, how they fly, what kind of motions we have, and how we control those motions. Now, the actual part, how you can build your own copter and what components do you need. So first of all, definitely you need motors, you need a flight controller, you need a speed controller, you need a gyro, accelerometer, compass, GPS, camera, radio. So these are the basic components. I'll give you a quick review about these components. Motors, you are very familiar. Motors you have seen in the toys. So we use similar motors, but a different kind of motors. We will see in upcoming slides. A flight controller is a special controller. It's a board. It's a device that controls the operation of your devices installed in the copter. All the devices, all the equipment, all the components are connected to the flight controller, and this flight controller is controlling those devices to make sure your copter experience is a good and you enjoy the flying. Speed controller are the controllers which are controlling the speed of the motors. If you in the previous screen, you see that in order to have a particular movement, I want to change the speed or the thrust of the rotors. In order to achieve that, I need speed controllers that control the speeds, and these speed controllers get the signal from the flight controller so that the speed or the thrust of the motors can be controlled. Gyro or accelerometer, okay? These are the most sensors required in the copters. These sensors, they are telling the flight controller what is the orientation of your copter, in which direction your copter is facing. Is it north, east, west, northeast? And the gyroscope is basically telling that how the copter is behaving. So these sensors, they send the signals to your flight controller, and the flight controller, based on these sensors feedback, it controls the speed controller to make sure that the copter is flying smoothly as required. A compass or a GPS, okay? A compass is telling you the direction in which the copter is flying, okay? And a GPS is telling you the position, the geographical position of your copter on a Google map. Why these are required? GPS is an optional component that depends on the type of flying you have or the type of copter you are building. If you want to have a mission-based copter where you use different copters to make a mission. For example, I make a mission that my copter takes off from my home, it goes to a nearby location, do something, goes to another location, do something, goes to a third location, do something, and then come back. So this is a complete mission that I'm going to feed to the copter. And all these mission waypoints, they are supported by the GPS so that it knows that where are the coordinates, what is the current location, where it has to go. So all these are controlled by the GPS, and the compass is controlling the orientation so that the copter moves in that particular direction to follow the waypoints given through the mission. A camera is an optional component. A camera is basically used if you want to have some aerial photography of your of your land or if your area, or if you are into FPV. FPV is first person view. This is the view that you get when the drone or the quadcopter is flying around you and you see directly through your goggles or on your screen. So the camera is optional. That depends on your requirement. And then you need a radio. A radio is not that FM or AM radio. It's a special radio that is used to communicate with your copter so that you can send different signals, control signals to your flight controller. That flight controller is going to control the speed controller, and the speed controller is going to control the motors. So there is a two-way communication. Why two-way? Because sometimes we use special equipment, special boards on the copters. Okay, which we use on different methodologies, and we use these signals to create create a two-way system called telemetry, where the flight controller is sending different kind of signals to my copter. Okay, so this is how a particular copter is assembled. Let me show you another view. So you can see these are the 4 ESCs. Okay, these 4 ESCs are connected to the 4 motors individually, and these ESCs are connected to the quadcopter. The flight controller. This flight controller is connected to a GPS. Okay, and this controller is also connected to a radio, a receiver, and it is connected and optionally to a camera. So all these devices are communicating to the quadcopter. Autopilot in this case is the flight controller. Okay, so what do you need to build a drone or a copter? So first of all, you need a motor with the propellers. These are special motors called brushless motors. The motors that we have in our toys, they are called brush motors. They are not good for building the copters. We use special motors, high-speed motors, high-torque motors, which are the brushless motors, and we need to have propellers on them. Then we use ESCs, electronic speed controllers. Speed controllers, they control the speed of the motors. Then we need flight controllers. We have different flight controllers available in the market from different companies. Then you need a radio transmitter that sends a signal to your flight controller. You need a receiver, radio receiver, that is connected to the flight controller that receives the signals from your transmitter. Then you need an optional camera, which is again connected to your flight controller. Then you need a GPS, and these GPS may or may not have a built-in compass. Okay, so how you can build a copter, or you can start building a copter? First of all, you need to choose a frame. What kind of frame you need to build? I'll show you a couple of frames. Okay. You must be seeing a special frame on the screen. This frame is a Cinevoop. A Cinevoop is used to do cinematography. Okay, if you want to capture videos or pictures of nature or of your land, you can use these frames. Or if you are into racing drones, you can use these mini frames. Okay, and if you are into more powerful stuff, you can have these special frames, the heavy duty frames. It all depends on the type of the drone you are building. Once you have selected a frame, you need to select different motors. We have brushless motors available in the market. These are the brushless motors. Okay, it has 3 terminals because this is a brushless motor, and These motors are specific motors that we use for the copters. Then you are going to use propellers. So we have different propellers available in the market. You can use a 3-blade propeller or a 2-blade propeller, depending on the type of drone you are building. Then you need electronic speed controllers. They look like these ones. Okay. Sometimes you may have a special board which contains all the ESCs in one board. So this is a special ESC which contains 4 ESCs on a single board. So you don't need individual ESCs, and you need a single board that can control your 4 motors. After that, you need a flight controller. The flight controller can be like this, or it can be different, depending on from which supplier you are purchasing it. A flight controller usually have a built-in gyro and accelerometer, so you do not need to buy and connect externally. Okay. And then you need a GPS. A GPS looks like this, or the one shown on the screen. It depends again on the supplier. These GPS have a built-in compass, and these compass and GPS, they tell the position and the orientation of your copter. Then you can use a camera. Okay, so once you have all these stuff, you need to power up using batteries. We use special batteries called LiPo, lithium polymer batteries. These are special batteries. You can use other nickel cadmium batteries as well, but the most popular ones are the LiPos, lithium polymer batteries. You can purchase from different places. After you have gathered all your hardware, you need a flight controller software. We have many flight controller softwares available in the market. The most famous ones are the iNav or Betaflight. Others are CleanFlight, ArduPilot, and many more. Okay. So once all these hardwares are ready, you can connect them with each other. Every controller, flight controller, has its own connectivity method or wiring method that you need to follow. Okay. So once you have set up the hardware, what you need to do is you need to do the configuration on the software part. So there are different configurations available based on the software that you are using, and there are different tutorials available that you can follow to do the configurations of these flight controllers. And after these configurations, you can do different tunings that are required to make sure that your copter is flying in a proper way and in a controlled manner. Okay, so that's all from my side. We have 2 minutes left for this particular session. Unfortunately, I'm using an unpaid version of Zoom. What I will do is I'm going to share another Zoom ID in the chat. Once this session ends, I want you to join the second session, and we are going to resume the webinar and we'll take the questions from that link. So let me give it a pause over here and create another Zoom ID for the next session. Just give me a couple of seconds. Okay, guys, welcome back. So let's wait for the rest of the guys to join this new session, and then I'm going to take the questions from all of you, inshallah. Uh, the format of the questions will be: you are going to send me a direct message. I'll be reading those questions from the message area, and I'm going to reply to them, inshallah. So whatever your questions you have, start sending me in the private chat. Okay. So how do you tune? Let's wait for the rest of the guys, and in the meantime, I will keep the questions so that we can answer at the same time. Okay. Let's resume the question answer session. I'm already recording this session, and those people who will be joining in later or they will not be able to join, they can listen to the recording because I'm going to share this recording with everyone. And if they have any question later on, they can always come back to me through email or through my WhatsApp number. Okay. The first question from one of the guys is, how do you tune the copter? Okay, in order to tune the copter, it means that you have to do the PID tuning. The PID tuning is the special tuning, which are the control feedbacks, proportional, integral, and differential parameters. And in order to tune a copter, what do you do is, let me share my camera so that I can explain to you. Okay, so what do you do is, this is your, for example, this is your drone, this is your copter, quadcopter. What do you do is that you tie this copter with a four-sided frame. For example, you have your table, sorry, a table or a chair, you put it upside down. So the legs are facing to the sky. So you tie your four legs of your chair to the four sides of the copter using very strong strings. Make sure that the strings are very strong and the knot is very, very strong. After that, you are going to fly your copter with the minimal PID settings. And based on the effect of your the reaction of your copter, you are going to change the PID values on all the axes, your roll, pitch, all the axes. You are going to change those values. So those values are basically your hit and trial, and these values depend on the weight of your copter, the weight of your motors, the weight of the LiPo batteries. So, for example, if I have this copter, my PID values will be different from the one maybe you are building, okay? Because maybe you are using a heavier LiPo. or lighter batteries or some other frame. So the PID values are different from the ones I have. So you have to do your own PID settings or tuning. So these are the basic PID tuning setup we have. Okay, thanks for your appreciation. The range of the drone. The range of the drone depends on the radio. Okay, so the type of the radio or the made of radio you are using, it depends on that. We have long range radios that can go up to say 10 kilometers, 15 kilometers. And in order to do that, you need FPV system because the drone will be out of your sight. So you need to have a camera with the FPV system so that you know where is your copter, and from your screen or from your goggles, you can control your copter. Okay. A normal radio that we use is containing basically a minimum optimal range of like 1 kilometer or 700 meters. So that again depends on the type of radio system you are using. Okay, how do you figure out the front of the quadcopter? Okay, the front of the quadcopter is basically controlled by the position of your flight controller. Okay, the flight controller has a built-in compass, or if you have an external compass that you install on your frame, and the direction of the compass tells you the nose or the front side of your copter. Okay, I'm not sure if you can see clearly or not. This is a flight controller, and you see that there is an arrow marked on this one. This arrow is right now pointing upward. So what if you will install this one? So the arrow is pointing forward. So this will be your forward or the front of your copter. Okay. Any recommendation kids for kids 12 to do a summer project involving all components assured? Okay. Uh, I will share a recommended list of the kit that you can use, but keep in mind, you cannot fly a drone in a public. You need a license or a membership from a flying society that manages your membership, and you have to go to a specific area where you can fly and test them. And you have to be very careful with that. Do not try to fly any kind of copter in a public area, otherwise there will be a legal action against you. Okay, what about the storage inside drone? It is in the terabytes. The drone itself is not storing anything. Okay, there are two ways of storing the information. One way is basically what information you are storing. You are storing basically your video footage. So what you will do is that the camera that you have installed on your system, it's going to send you back the video stream that you are going to store on your ground station, or you can store that data on the SD card available on the flight controller. That SD card option depends on your flight controller. Not all flight controllers have the SD card. The another way is to use the cameras that have a built-in SD card. For example, you can use GoPro, you can use Hero. These have the built-in SD cards, and these SD cards, they are storing all the data. The other way, complicated way, is to use the telemetry. Okay, telemetry is a special radio that you connect to the flight controller, and this telemetry is sending all the flight controller data, the GPS coordinates, the logging of the flight controller, all the kind of flying data is sent back to your ground station using the telemetry. Okay. Okay. If you find something wrong during your tuning, what do? Simply you change the PID settings of the particular axis on which you are facing a problem. Any regulations considering while selecting radio frequency and power? Usually these radio frequencies, they are available. You can check with the local authority that what is the allowed radio range uh, suitable for your particular area. That depends on the geographical location and the authorities around you. You can check with the local flying club. They can guide you. What is the best drone you suggest to capture the digital terrain model, videos, and images in hilly areas? Guys, this depends on your on the architecture of your drone, how you build a drone. Okay, and it depends on the flight controller, it depends on the motors, it depends on the radio. So as you are building a customized your own quadcopter, you have to be very tricky and you have to be very careful, and all these selection depend will in the end affect the quality and the output of your drone. Okay, uh, this cinematographic drone I'm building right now, that's equivalent to a DJI. Okay, it has almost all the functions like a DJI. It can do hold in the air just like a DJI. It can stay in the air. It can maintain its altitude. It can take the photos, pictures, go to the mission using the GPS and a compass, come back. So this you can use for the same purpose. This one can also be used, but it's a more heavier one because the motors are very special. The propellers are the bigger ones and they are kind of unsafe. There is no protection around them. So the selection of the hardware tells you how your drone or copter is going to perform. Programming component is the flight controller that you're going to program using the iNav, Betaflight, Greenflight, or Autopilot softwares. How far you can fly a drone without a license? Not even a single centimeter. You need to have a license unless or until you fly your drone inside your home, or if you have a villa, you don't go outside the boundary, or if you are in the farmhouse, you can do that. But make sure to do it on your own responsibility. I or anyone else is not responsible. So you have to have the license or the permission to fly a drone. We don't have any simulator like that in my knowledge. Maybe if there is, I will let you know. Okay. Okay, for getting the license, I will share the details over the email for the ones who are interested. For the license, we have two bodies over here. One is GACA and other is the Tahagum. Okay, these two bodies, they issue the license for the planes, aeroplanes, and the copters, helicopters, and these kind of aircraft. So whoever is interested in getting the membership and the license, he can send me a separate email, and I will share the details with him. Okay. So guys, we are almost done. Uh, thank you very much for joining this excellent session. Okay. Regarding the parts required to build a drone or a copter, I will share the details in the email. Some recommended parts that you can buy. Okay. And regarding the license, there is no age limit. Anybody can get a license unless or until he can control. You have to demonstrate that you can control your aircrafts. You have to give a demo. You have to give a test, just like a car, and then you can have it. Okay. Here you can see some different workshops that I'm usually conducting during this summer vacations. As I told you in the start that I'm not only having the hobby of this quadcopters, I'm also other expertise, and I'm conducting different workshops for these. If you want to participate in these workshops, you can visit these links and register yourself. The workshops will be starting from this weekend. So if you are interested, try to hurry up and register yourself. Okay. Regarding the workshop about the drone building, I have not designed it yet because I didn't expect that I'll be getting this much good response, because this is a very different subject. I will design a workshop and I'm going to share with you all once I have the design ready, the contents, and during that we will see how we can build a drone. And before that, I will check with the authorities that if I can deliver such workshop. Okay. Thank you very much once again. It was a nice pleasure to have all of you in this webinar. If you have any questions, you can come back to me through email or through my WhatsApp number. Okay. Uh, and if you have any suggestion to improve these kind of webinars, drop me a message, because the purpose of these webinars is to make sure that you learn and you get the information as per your expectations. Okay. Thank you very much, guys. Thanks for coming. Take care. Allah Hafiz.